All right, well, I'll start us off. Thanks, folks, for being here. My name is Dave Sly. I'm with Wild Virginia, the Conservation Director. And you're going to be hearing a bit from me tonight, and also Autumn Crow from West Virginia Rivers Coalition, and Jake Lemon from Trout Unlimited. We'll be passing the baton back and forth here a little bit. We've all been involved in this program for quite some time, and I feel like you're going to get some important things out of this. We think it's really important for citizens to be out there looking out for your waters in your neighborhood, your area. First of all, you know more about it than most people. And second, you can be really useful through a program like this. So I'm going to first hand it off to Autumn, who's going to tell you a little bit about the how this thing's going to work.
Thanks, Dave. So welcome, everyone. I'm going to go over just some general housekeeping items, get you familiar with Zoom. This session is being recorded, and the recording will be sent to you following the session so that you'll have access to it at a later time. If you look at your Zoom controls in the bottom of your screen, you'll see your mute button in the left-hand corner. Please make sure you mute yourself so we have minimal disruptions. And following the presentation, we'll be doing Q&A. And so you can enter yourself into you can enter your questions into the chat. There's a chat box there. So you can enter those questions at any time. And then if you click on the participant list, you can rename yourself if you want to put your name in there. And like I said, we'll be doing Q&A following the presentation. And so enter those questions at any time in the chat box, or following the presentation, you know, we are able to have an open discussion. So you can unmute yourself also if you have questions that you want to ask verbally. And then there will be a sign-up form dropped in the chat box towards the end of the presentation. And that's a way for us to figure out which state you're in. If you're going to be monitoring in Virginia, you'll go with Wild Virginia. And then if you're from West Virginia, you'll go with West Virginia Rivers Coalition. So with that, we have a few polls that we want to launch. So I'm going to go ahead and launch those polls just so we can learn more about you and your previous experience. There we go. Okay, so it's a mixed bag here. There's about 60% that have voted, so we'll give it a few more minutes. So it looks like, let's see, votes are still coming in. I'm going to close it in a few seconds. I think you'll be able to see the results. Looks like we've got about 60, a little over 60% with no experience in previous trainings, 30% with water quality monitoring experience, and then 10% with visual assessment, and just under 5% with Save Our Streams training. So you can see the results there. That gives us a better idea of, you know, what kind of experience you have previously and how in depth we should cover these topics. And then we have one more poll, and that's to just see where you're at. Okay, so 80% have voted, so I'll go ahead and end the polling and share the results. Few from West Virginia, and then it looks like we've got half and half, Virginia and other. So I'm curious to see where all those others are from. Panama, Philippines. Okay. North Carolina, Toronto, wow. All right, well, that's it for me for now. You'll be hearing more from me later on in the presentation.
Okay, so what we're talking about in this training is basically just what we call visual assessments. Clearly, there's a range of things you can do to check water quality, to look for impacts from pollution. And probably the most simple one is visual assessments. You go out there and you look around, you take notes, you take photographs, and that can be a pretty important tool. A lot of the pollution problems are or can be fairly obvious. And basically what we're mostly looking at is different types of construction sites. In some cases, it's big projects like natural gas pipelines that we have all been working on in West Virginia and Virginia. But it can be any basically what they call a land disturbing project, where they're grading and taking away trees and disturbing the land, which can have big effects on the water nearby. So you'll be looking, if you go to a site, you'll be looking at what they're doing on the land. So we'll tell you a little bit about what that should look like. If you're doing construction, these are some of the things you should be doing to protect the water. And what should the water leaving the site? What should the streams nearby look like? There's a little bit of art to how you photograph and how you document these things. It's not as easy sometimes as it seems to get a good view of what's really going on at a site. So we'll talk a little bit about that. And then finally, once you're out there, once you get some observations, what are you going to do with them? And so we'll go through that also. And now I get to hand it off to Jake, who's going to tell you a little bit more about the program.
Sure. So yeah, my name's Jake Lemon. I work for Trout Unlimited, and back in, I guess it was 2013 or 14, we initiated the West Virginia Water Quality Monitoring Project, really getting our start in West Virginia in partnership with West Virginia Rivers Coalition, and then expanding into Virginia in partnership with Wild Virginia. And really the goal of this project was to provide training and technical support to local communities, watershed groups, Trout Unlimited chapters, just concerned citizens, to be able to be the eyes and ears on the ground and identify and document pollution incidents that may be occurring as a result of shale gas related development. As some of these larger pipelines were proposed, and we kind of expanded that program to focus a little bit more on pipeline development and some of the erosion and sedimentation issues that can come along with that. And so the program has grown over the years. We have a combination of folks out doing water quality monitoring, so actually taking measurements of parameters like turbidity and temperature and conductivity, and folks who are out doing visual assessments, as Dave mentioned, documenting things that they are observing on the ground. And so this webinar is basically sort of an extension of that program, where we're providing some additional training, and Wild Virginia, and Dave will talk here in a bit about how they're looking to broaden the types of projects that we're monitoring. So I'll kick it back over to Dave.
Okay, and I was just looking again at where all you folks are from, and it's it's kind of amazing to have such a wide spread around the world. And so, to be honest, some of the stuff that I'm talking about directly in Virginia obviously is not going to be of much interest to you, but the point is that a lot of the kinds of problems that we have here, you probably have in your area too. Autumn can certainly testify that a lot of the same things happen in West Virginia. I've worked in a lot of other states, and they're kind of common. So one of the things Wild Virginia has done in working on these pipeline cases, one of the things that we have kind of revealed is that the way the state of Virginia at least regulates or supposedly regulates construction activities, despite the fact that those programs are supposed to be designed to stop water pollution or prevent it, they don't always work. And part of the reason is that the regulations aren't as strong as they could be in some ways, but also the way those are applied just doesn't, basically what happens on the ground doesn't match the theory of the way it's supposed to work. In Virginia, and again, in probably a lot of other places, what they issue in many cases is coverage under a general permit. And that is a permit, it's kind of a one-size-fits-all thing. You say, if I want to do construction in this state, I'm going to ask to be covered under this permit. It has some general requirements that everybody in the whole state is required to live up to. But what we know is those requirements aren't good enough because, you know, in one part of the state, we have trout streams that are very sensitive. In another part, bigger rivers, you know, so there's a range of areas, a range of conditions that you have to account for. And so part of what we're trying to do, we've started it through the pipeline monitoring, but we're trying to broaden it and continue it. And that is to look at really more sites, and not just pipeline sites. So yeah, I'll move on from there. So, well, I've already talked about the general permits, and again, there are thousands of projects. I actually have the list now of all the ones in Virginia that have been covered under this so-called general permit. And so what we're trying to do is figure out, when they do what they're required to do, whether it's working or not. And the fact is that we know in some cases, BMPs, which if you don't know, those are called, or that stands for best management practices. So there's a standard set of things that they're supposed to do to keep the sediment and other pollution from leaving their site. So one thing you'll see is sometimes those things aren't in place, or they're not done the way they're supposed to be. But one of the things we also know is that sometimes they're in place, but the streams are still getting damaged because they don't work the way theoretically they're supposed to. So we are particularly concerned about things like turbidity or sediment, but also some other problems that you'll see in a stream around a development site. Next slide. So, as I say, we're trying to kind of broaden. We still have some pipeline fights here, as people in Virginia know. So we're still watching those kinds of places. But as I say, we want to kind of expand out and look at some other places. For one thing, geographically, it makes sense for us to look at some different places in the state, plus some of you out there who are in Virginia are spread around, and we want to find places that you know or that work for you, that you can get to. Again, it's not a departure from what we've been doing with pipelines, really, as far as the methods. It's just maybe a little bit about how we're going to use it. Now, part of the thing the pipeline monitoring, we've done it on a regular basis, or the monitors go out on a regular basis, whatever the weather happens to be. And then during construction, they have done some more frequent monitoring. One of the things that I'm going to be particularly looking for is folks who are willing to go out there and get wet. I'm going to want to see some results during or soon after storms, because obviously that's the time when a lot of the pollution is going to be leaving the sites. Next, please. So, as I say, I've got this huge list of thousands of places, and I'm working on narrowing it down, finding some of the places that seem like they would be best for our purposes. So, for folks in Virginia who want to be part of this effort, I'll be following up with you and trying to work with you, probably in small groups through Zoom or whatever, so that we can kind of compare notes on where you are, where sites that I'm particularly interested in are, and how we can match you up. And again, there are lots of them, but one of the things is when choosing a site, can you get to it? Is it safe? Can you monitor around it without trespassing? All those kinds of things. So it'll take maybe a little bit of back and forth between us and you to make sure you have sites that work. But I'm certain that we can find them for a lot of you folks. Next slide. And one of the things that we might do, Jake talked about the fact that sometimes folks are doing actual measurements or samples, and we may be doing some of that. In some cases, doing the visual assessments can be a first step. You can help us figure out where we want to do a little more intensive monitoring or sampling. And we intend to use this information. One of the things we have shown already with the folks who have monitored around pipelines is the streams they're monitoring that are not affected by pipeline construction upstream or before construction starts, is a lot of these waters are in great shape. And that in itself is useful information, because then we can go to the government folks and say, you know, you really got to recognize that these places are high quality and they need to stay that way. But as I say, we really intend to use this information. So I'd just like you to understand that you're not just doing it, you know, and it's going to be ignored. If we can get information, it can really be effective at changing the way things work. If you don't know, I'm one of those damn lawyers. And so I know a little bit about how to make the law work. And I know that your input can be important. Next slide, please. Sorry if that offends any lawyers, but
well,
most lawyers can't be offended anyway. So.
Thanks, Dave. All right, folks. So now we're getting into the portion of the webinar where we're going to talk about, you know, more specifically what we are looking for volunteers to do. We'll cover some very high-level basics of the types of water quality monitoring that we might employ. You know, talk a little bit about the parameters, an introduction to the methods. You know, in the follow-up that occurs after this webinar, Dave will be connecting with interested volunteers, and you know, if you were to take part in some of the water quality monitoring work, there would be some additional training that would go along with that. And then the visual observation, which is where we'll spend most of our time in this webinar. The methods here are, you know, we've been training these methods via webinar in the past, and they can be trained that way. And you know, hopefully you will leave this webinar feeling like you have some, you know, some comfort with conducting visual observations around earth disturbance projects. And so, you know, I can't stress enough how important both of these aspects of monitoring approaches are to protecting streams. And, water quality gives us a numeric idea of, numbers, actually assign numbers and concentrations to let us know, what the quality of a stream is, before potential impacts, and also by monitoring water quality above and below earth disturbance sites, we can compare basically upstream conditions versus downstream conditions and have some idea if there's impacts. And then visual observation, taking photos is really, especially in our work with state agencies, is often the most effective means of getting state agencies to act on pollution events. If you can provide them good photographic evidence that a problem is occurring, you're much more likely to sort of mobilize their inspection staff and get them out there. And so we've had good success with that. It's in West Virginia, at least. And so, we'll move on. So yeah, first talking about water quality. The main parameter that we're looking at when it comes to earth disturbance projects is turbidity. And turbidity is just the relative clarity of water. Basically how easily, is it very clear? Is it cloudy? Is it you can't muddy and you can't see through it? It's basically a numeric value that lets you know how clear water is. So it's affected by suspended material in the stream. So this can be sediment coming off of a construction site. So, soil, sand coming off a construction site and into the stream. It can be affected by algal blooms. It can be affected by basically anything that's just any kind of suspended material in a stream. And it's measured in kind of a funky named unit called nephelometric turbidity units, which also known as NTUs. So that's the unit of measure, kind of a standard unit of measurement for turbidity. There's lots of different ways to measure turbidity, ranging, from just ranging from little test kits to high dollar optic sensors. And we have employed what's called a Secchi tube, or a turbidity tube, to measure turbidity through our program. And basically it's a way for you to look through a column of water and see how far down you can see. It's a visual measurement tool. And so basically you're filling a tube with water and dropping a weighted disc through that water column down this tube and seeing how far down you can see through the tube. And so again, if you were to take part in the water quality monitoring aspect of this program, we would give you actual, hands-on training on doing those measurements. And Wild Virginia has, they provide that training and also provide that equipment that they have in-house. So turbidity, super important. In some states, there are numeric standards for turbidity. So basically states will hold permitted projects to a standard as far as you can't add this many NTUs of turbidity to a stream. And some states do not have numeric turbidity units. It's more of a qualitative description, like, you can't, basically saying you can't muddy up the stream. And so West Virginia has numeric, Virginia does not. But it's a useful way of documenting small changes in water clarity. Conductivity is another one we look at. This is the ability of water to pass an electrical current. And it's basically, it's dependent upon dissolved ions in the water. So every stream and river has a baseline conductivity that's just, based on, if it's 100% forested, or, it's 100% undegraded, it's going to have a baseline conductivity that's based on the geology, the types of rocks in the watershed. But as you, you change the landscape, whether it's, developing for urban uses, or if there's things like gas development, there's different types of, you start to introduce different types of dissolved ions in the stream. Things like road salt for, road salting for during snows, things like that will introduce these dissolved ions in the stream. And conductivity is basically a cheap way to monitor lots of different things that are in a stream. So if you have your baseline conductivity, if you see that rise dramatically, basically what you know is that there's something in there that wasn't in there before. something that's measurable by conductivity. And then you can do follow-up sampling to actually hone in on specifically what it is in the stream that wasn't there before. So it's basically it's kind of an inexpensive way of broadly tracking stream health over time. And so we measure it using a little handheld sensor. It's a Lamont tracer pocket tester. The unit is microsiemens per centimeter. And we also use that tester to measure temperature. You may be measuring water and, or maybe air temperature as well. But water temperature is extremely important. It affects all kinds of biological and chemical processes in water. Trout Unlimited, we're an organization dedicated to conserving and protecting cold water fisheries in their watersheds. So trout, salmon, fish like in that, in the salmonid group rely on cold, clean water. And so those, brook trout, for example, which is the native fish in Virginia and in West Virginia, really don't handle water temperatures over 68 degrees very well. They need colder stream temperatures, and there's a potential that some of these projects could increase stream temperatures. So we look at that as well. And again, that's measured with the pocket tester. So I'm going to kick it over to Autumn.
Thanks, Jake. So now we're going to get into a little bit of the BMPs that Dave was referring to earlier, and those are the best management practices that any company that is going to develop an area, generally over a few acres, will be required to get a permit, a stormwater permit, a construction permit. And so when they get that permit, they have to define what their best management practices are going to be on the site to control the sediment and keep it from leaving the site and entering streams. So we'll go over some of the best management practices that you will commonly see on construction sites, and then we'll go over how to determine whether they're working or whether they're failing. So one of the BMPs that will be used for very steep slopes, and we'll be using a lot of pipeline photos, but this would apply to any kind of project, whether it's a highway project or I guess there's not too many projects where you develop really steep slopes other than ski slopes. But one of the ways that they control the runoff from going all the way down that steep slope is through slope breakers. So we commonly refer to these as water bars. And this is basically a diversion ditch that goes all the way across the construction area to divert the water off of the construction site. So you don't want the water flowing right down the disturbed soil. It would basically create like a river. So they'll have these slope breakers or water bars spaced evenly depending on how steep the slope is. So there's different standards for the steepness of the slope, how far apart they have to be placed. So those are the slope breakers or water bars. Another BMP that's used a lot is just mulching, or they'll use mulch or wood chips or hay. And this is just to cover the disturbed soil before they can get vegetation established. So basically you want to protect the soil from the water because once the water interfaces with the soil, that's where the erosion occurs. So they'll put down some mulching, wood chips, hay, to keep the soil in place for rain events. Instead of like mulching prior to vegetation, another device that they'll use is mesh matting, and it's kind of like a cover, like a kind of like a fabric cover that goes over the soil that protects it. So you'll see a lot of the mesh matting along steep slopes where runoff might just wash away hay. So they'll actually put the mesh matting down and then tack it into to hold the soil down and prevent the water from eroding the soil. And then obviously they'll want to establish vegetation following construction. So once they're done, then they revegetate the area and they restore the area and plant some grass to hold the soil in place. And this is more of a permanent erosion control measure. So a lot of the most commonly used BMPs that you'll see are like these sediment barriers. They're either a silt fence, which is like a fabric fence, or a filter sock, which is like the snaky one that you see in the right side of the slide. And so these are often used, they're used a lot, and they're often used as perimeter controls around the site. So they'll put down the silt fences and the filter socks around the edge of their disturbed area to keep that soil from migrating off the site. So these are the ones that we see most commonly on construction sites. And then, so now that we've covered some of the BMPs, what we will want to cover is what to look for when you are out at the site. So first of all, you want to look for any kind of earth disturbance that goes to the edge of the water body, and if there are no erosion controls in place, that's where the damage is going to really occur. When you have disturbed soil right up to the edge of the water body with no erosion controls in place, then that just allows the soil to go right into the river or stream. So that is, the number one thing to watch out for, is to make sure that there are some kind of controls in place where that soil, that disturbed soil, meets the edge of a water body. Another thing to look for is any kind of erosion gullies leaving the site. And so the whole point of all of their BMPs is to prevent erosion, both on-site and off-site. But there can be some erosion on the site that's controlled by perimeter controls. But if you see that there's erosion gullies leaving the site, then obviously their erosion control measures are ineffective. So generally there's erosion gullies leaving the site because their erosion control measures have failed. Another thing to watch out for is bare soil where there's no mulch, or the mulch has been lost due to erosion events. So they have to minimize the bare soil and control erosion. So if you see a lot of bare soil, the chances are you're going to see erosion. So that's something to look out for, is to make sure that where there is bare soil, they have some kind of control measure in place to protect that soil. Otherwise, if you have a rain event, it's going to erode. And then another thing to watch for is failing slopes. And this, would mostly occur on steep slopes where it's virtually impossible to hold the slope, the side of the mountain, in place when they've disturbed all of that soil. So all of these measures that they use are in place to keep the slopes from failing: the water bars, the silt fences, the vegetative cover. And so when you see failing slopes, That generally means that their diversion ditches are no longer working, or their water bars, they've failed, their vegetative cover isn't working, and so that's something that you want to watch out for and report, because that's something that they are supposed to prevent from occurring. Now we're getting into the silt fence bloopers. This is probably the most common thing that we see on construction sites where their erosion controls are failing. So they are required to maintain all of these erosion control measures, and they're supposed to check them very frequently after rain events. And if they are reaching capacity, then they are supposed to dig them out or replace them. But what we see is that, they have these little slips of fabric that are trying to hold back entire hillsides. And obviously that's not going to work. So that's something to really watch out for, is anytime that there is a silt fence that is overtopped with soil, or just gets buried. You might be able to see in the photo on the right, there is a green filter sock under all of those leaves. And obviously that is not working. So they have to be, these silt fences and filter socks have to be maintained. And if they get overwhelmed, if they get overtopped with soil and sediment and leaves, then they need to be replaced so that they can function properly. And so here's some more examples where they're not functioning as they're designed. So they're being used for purposes that they're not designed for, I should say. So silt fences are designed for sheet flow, to control sheet flow. That is water that's spread out over an area that they can catch. They are not designed for concentrated flow, as in you see on the photo on the right, where there's a concentrated flow there, and the water just pours right over top of the silt fence. And then in the other photo, it just could not withstand the pressure of all of the gravel, so it overloaded. So when these silt fences are not put in place properly, that's when they fail. So they're not designed for concentrated flow, and they also have to be buried in the ground a little bit so that nothing can flow underneath of them. So you'll see the one on the right, obviously that one is not as it is designed, and so the sediment can just go right underneath of it. So you really want to make sure that there's nothing going over top of them, and there's nothing that's undercutting underneath of them. And also you want to make sure that there's no holes in them. That's one of the major issues that we see they've been punctured in some way. So they get a hole in them, and then the sediment laden water is able to leave the site and enter the stream. So you want to make sure that they're structurally sound as well. And so anytime that they're not functioning properly, you'll see something like in this photo where there's sediment discharge that has left the site and is then able to impact a nearby water body. So we wanted to give you an example of what a good construction site is supposed to look like, so that you will then be able to see what a bad construction site looks like. I mean, obviously you're going to see disturbed soil, but you want to make sure that their water bars are in place. And one thing about the water bars is that they need to, so they're diverting water off the site of the disturbed soil. So they have to go all the way to the edge of the disturbed soil. A lot of times we see the water bars end on a fill slope, so an area where there is still disturbed soil. So it doesn't actually help the water diversion. It just releases all of the water in disturbed soil and creates an even bigger mess. And then also at the end of those water bars, they have to have some kind of treatment, some kind of filter sock or silt fence at the edge of the end of the water bar, because you're diverting all of that water off site. But you want to make sure that when the water leaves the site, it has some kind of filter to catch the sediment. So at the end of the water bars, you'll see some kind of treatment. So this is a good site. They have perimeter controls. They have the water bars in place. We didn't really cover trench plugs, but that's for specific to pipeline construction on steep slopes. You'll see there's like a plug inside the trench, and they have to do that every so often so that those trenches don't become basically a conduit for all that water to go right down the trench. So that's an example of what a good construction site looks like. This is an example of a bad one. They only have a few controls in place. They don't have any water bars, and you can see they're creating a pretty big mess of that slope. And then this is an example of a really bad one where they just basically have their site has liquefied. If they don't have any erosion controls in place, the site just turns into a big mud pit. And you can't even tell in this photo, but there is an actual stream underneath all of that mud.
And I'm just going to jump in real quick and make a point that I intended to make on one of my earlier slides, is that as you see here, I mean, this is like worst case scenario, but what we're really trying to do through this type of monitoring is keep sediment out of streams. And sediment is a pollutant in itself, mostly as it relates to aquatic life. So fish, bugs that live in the stream, other critters rely on, you know, and especially in Virginia and West Virginia, rely on like a rocky, in these systems that we're working in, rely on a rocky, pebbly substrate. So that's like their habitat, that's where they live, that's where they eat, that's where they build, you know, trout, for example, build their nests in this gravel and reproduce there, spawn and reproduce. And when you fill streams with sediment and smother these gravelly habitats, you significantly impact the aquatic life in that stream by smothering the places, again, where they live, where they reproduce, where they're feeding, that sort of thing. So it's and then obviously there's drinking water concerns as well downstream, where, you know, if municipalities are taking in muddy water, it's much more expensive and difficult to treat. And then sort of aesthetic concerns, whether it's folks who are just enjoying the river or fishing or whatever. You know, it's in these, again, a lot of these places where we're working, these cold, pristine, small streams off in the mountains, they're really, you know, most of the time running clear. And so it's a significant impact to the habitat. Okay, I just wanted to jump that in there real quick.
Yeah, thanks, Jake. We definitely want to make sure that we get that point across. Yeah. So, you know, as Jake was mentioning, you know, we really need to keep this sediment out of the water bodies for multiple reasons. So if you see a sediment plume in a body of water, that is a major problem. And so, you know, document the plume, but, you know, it's also really important to try to find out where that sediment is coming from. So if you see a plume of sediment entering the river or the stream, and you can investigate upstream to try to find the source, that's going to be really helpful. And so, you know, anytime you see discolored water, it can be from sediment. If there is boring going on, either for like fiber optic lines or pipelines, they use a drilling mud a lot of times to bore. And so sometimes that can also enter the stream. And so anytime you see discolored water, you want to document it and then try to go upstream and find its source. Sediment deposits in a riverbed, if you know these rivers and streams in your backyard and they have like that stony, cobbly composition that Jake was just referring to, and you come back to it and you see that it's filled in with silt or sediment, leaves, any other kind of debris. I mean, some of that can be natural from flooding, but if you haven't had any recent flood events and you see a lot of the deposition from sediment, then that there's a source of sediment that is releasing that into the stream. So you want to try to investigate to determine where that sediment is coming from. It could be naturally occurring eroding stream banks or something like that, but it could also be from a construction site. And then another thing to watch out for is oily film on the water surface. Now you have to be careful with this. We get a lot of like false positives because there are also microbes in wetland areas that they create this bio sheen as part of their metabolic process. And so there's a difference between petroleum film on the water and that naturally occurring microbial sheen. So the way to tell the difference, I often tell people to poke it and swirl it around with like a stick or something. And if it congeals back into place, then it's most likely petroleum. If it gets kind of like breaks apart and is kind of like blocky and it doesn't kind of congeal back together right away, then that's more of the naturally occurring sheen. Of course, the other way to tell is the smell. You'll be able to tell the smell of petroleum. And so you also want to look for, if you see that film, look for the source. Are there any drums nearby? Is there a road nearby? A lot of times if there is an oily sheen, like a petroleum sheen, then it's coming from sources either from a spill or from drums that are leaking or something like that. So if you see petroleum, that's, it's first of all, it's toxic and it's very harmful for people and aquatic life. So you don't want to get in the water. You want to protect yourself. And then you also want to try to find the source of that, because that's a major issue that you should be reporting right away. And then related to that, if you see any fish kills, we can get fish kills from lack of oxygen in the water. So you might see that happen in some lakes and stuff where they don't have enough oxygen content. But if you see a major fish kill in a flowing river, then you know that there is some kind of pollutant source that's killing those fish. And you definitely want to document that and report that. Another thing to look for, so any kind of road, I guess aside from timber operations, any kind of construction access road should have gravel on it. And even timber operations should have gravel leading onto a main public road. So anytime you see an access road that doesn't have gravel and is tracking soil onto a public road, that would be a violation of their permit. So look for mud or sediment leaving the main roads because their permit requires them to keep that sediment on site and keep it from entering a public road, because that's also a public safety hazard. So erosion gullies on a roadway, that's something that they would be required to prevent in their permit with their BMPs. And then finally, after the construction is completed, they have to restore the site. So a lot of times they do this with vegetation if it's a permanent restoration. Sometimes when they just are stopping temporarily, they'll use, we're finding that they're using these tackifiers. They're like earth guard pellets, and they just spray them, usually from like a helicopter. They release them, and it's like a, well, it's a trade secret. I don't know how exactly it works, but it holds the soil in place without vegetation. So we're seeing them do that a lot on the pipeline right of ways. And if you see those pellets, especially if you see them entering a stream, that, you know, they have to keep those out of the stream. But if you see the area is lacking vegetation, but they have put those pellets down, then, you know, that basically meets the requirements for their temporary stabilization. But following completion of the project, they should have the area at least 70% vegetated to get out of their permit, to be released from their permit. So if you see it's an area that should be restored, but it doesn't have proper vegetation, that's something that you would also want to report.
All right, thanks, Autumn. Got 10 minutes left, so I'm going to try to zoom through these to get a little bit of time for Q&A. Let's talk a little bit about when and how to conduct these types of visual assessments. Really the focus of this Wild Virginia campaign, and really the focus of when you're likely to see impacts of erosion and sedimentation, are during and after moderate to heavy rain. So if you think about it, rain's hitting the ground, running into the streams, picking up you know, sediment along the way. It's when you're most likely to have these issues. Weekends and holidays can be good, because if, you know, failures occur, there's less likely to be, you know, state, you know, agency folks out there keeping an eye on things, both during and after construction. So there's, you know, there's pipeline projects in West Virginia that have been done for over a year, are still having erosion and sedimentation issues. And so it doesn't end just when construction ends. Really, it's, you know, you'll want to be keeping an eye until vegetation is complete and the area really seems stabilized. Quickly, some general rules and personal safety considerations that you should think about. Really one big one is to respect private property. A lot, you know, our folks are out that are volunteering through our various programs, are out driving around, looking at construction projects. And we just want to make sure that folks are not entering private property to get a better view of what's going on without landowner permission. You know, often we recommend folks do this work from roads, and again, properties you have permission to access or public lands. Don't, you know, if you're observing a construction site and you're confronted, you know, be courteous to folks. If you avoid confrontation, if things, you know, if you have if a confrontation, start with like a work, you know, somebody working on the site or something, just leave. A big one is don't place yourself in a physically dangerous position. You know, don't wade in the stream when the water's high. Don't try to scale a really steep bank in order to get down to the stream to get a better view of what's going on. Your personal safety is more important than any of the information you would collect. And then, you know, this is just sort of a broad statement, but if you see something that might create a public health or safety hazard, you'll want to contact your local emergency management service. And so, you know, this is in regards to things like, you know, our pipeline programs where folks, you know, if they were to observe a damaged pipeline or something like that. So how to document the issues. The best way is through good photos. We want to take photos and videos of the things that you're seeing. You want to take both wide angle photos that bring in, you know, the context of what's going on around the issue. Maybe if you can capture the stream and the construction site, or, you know, there's various iterations that could take place. That's good. And then follow that up with close-in up photos of, you know, the failed erosion, the silt fence, or whatever it is that you might observe. If you just send a photo that's just a real close-up of a torn silt fence, it's really hard for us to understand, you know, what impact that's having and follow up accordingly. If you can, if you're observing a erosion sedimentation issue in a stream, it's good to document the downstream stream conditions versus the upstream stream conditions. So again, if we have muddy water coming in and it's muddy downstream and clear upstream, and you can document that with photos or videos, that's useful. It's good, you know, you can travel downstream to document the extent of the issue. So basically, how far is that mud traveling? But it's also great to document the source of the issue. So if you just see a a sediment plume coming through, or if you're on a river or stream you know really well and it's muddy and it hasn't been raining and you don't understand why it's muddy, you got to go upstream to figure out where that's coming from. And of course, respecting private property. And so that's an important aspect, is if we can identify a source, we're that much closer to being able to fix it. As far as actually taking your photos, if you're using a digital camera, make sure the date stamp is correct. It doesn't look good to send in a photo that says it was taken in 1952. Turn on location services if you're using a smartphone. If we can have the GPS coordinates of the photo embedded in the file, it just gives it that much more credibility. You want to describe the photos and the videos, so have a good understanding. It's good to take notes and write down what you're taking photos of so that you can accurately and effectively explain what these photos are showing. Torn silt fence, water running into the stream, erosion gully, creating concentrated flow that blew out a silt fence, things like that. A really great photo, and I'll show you an example of this here in a second, is a plume of muddy water entering an otherwise clear stream. So that is a photo that is most easily actionable. We found with agencies that if you see like a water quality violation, whether it's a failed B&P or whatever, with muddy water coming out of the site and into the stream, it's pretty much, what's going on there and there's no arguing it. So that's like a very effective photo. So some examples of photos that are difficult to interpret. The one on the left, I think we're looking at a torn silt fence, but if we only receive that, it's really hard to understand if what we're looking at is actually something that you would report to an agency, for example, or if it's actually something that's impacting the water body. You would want to couple that with wide angle photos showing what's happening as a result of that. Same with the photo on the right. I know you can't really see what's going on. It's hard to tell if there's any actual erosion issue taking place. This is a great set of photos. This is two photos of the same issue. One is from a bridge where you're looking down on the left and you can see the water backed up to these silt fences, and then mud making it through the fences and then eventually out. And then the second photo shows how that mud is washing into the river. And so you're getting the full picture of what's going on there. And that's just a great example. It tells the full story of this particular erosion issue. So we need photos and we need location information. The best way to provide location information is through GPS coordinates. There's tons of apps out there that will enable you to do this with your smartphone. Google Maps, you can take GPS coordinates of your location. If you get involved in the program and you don't have that ability or know how to figure that out, I'm sure David or Autumn will help you out with that. These apps don't need cell coverage to work. Most of these GPS apps will work anywhere, regardless if you have cell service or not. If you can't do GPS coordinates, you'll want to write down very detailed descriptions or instructions to find the location. Basically, you want someone to be able to look at what you send and find that exact point that you found and where you observed the issue. So I'm going to kick it back to Dave as far as where do we go from here?
Okay, so we know we have several categories of people. The folks that I can work with, want to work with, are people in Virginia. And I do know that in our initial sign-up list, we weren't sure where some of you were from. So if you're in Virginia and you want to work with us, we need to make sure that we know that. Folks who are in West Virginia, I know that Autumn is still interested in folks there. If you're somewhere else in the country or in the world, I'm sure there are groups in your area that you can hook up with, things going on in your community. I hope for you that this has given you some information. But as far as next step, it's going to be hard for us to help with that. So the folks who are in Virginia, I'm going to be sending a follow-up email probably tomorrow, just so that we know we're going to be in touch. And in the next couple of weeks, I'm going to be starting to figure out some places where it seems like we could use somebody. And we're going to try to figure out how to match you up with the places that we're interested in. And as it says, that I think it would probably be a good idea just to have some follow-up Zoom meetings to get together and talk about these places. And so again, if you're in Virginia, you want to work with us, make sure that we know that and we have the right email so that we can follow up. And it'll be a little bit of a back and forth because, like I say, there are a number of factors that will go into whether it's a good site. And we don't want people going to sites where it's going to be dangerous. So we want to do a good job of protecting you and finding places that are really useful for us. So I'll stop there. And I guess we want to go through some of these questions that folks have given us. I saw, okay, sorry, I'm just strolling through. If any of the others want to help answer some of these that you see. Oh, here's one. How do you avoid trespass issues when monitoring construction sites? It's kind of, as Jake said, a lot of times if you're on or right next to a public road, that's going to be the best place you can see things and be safe, again, as long as you're not in a busy road. Most sites you can figure out where the boundaries are, and you just can't go there. It is true that sometimes it's hard to see or to get to the stream. Again, it's going to take a little work to figure out what sites work and how to make them work. Does that make any sense? What else we got here?
I see one that says, what method procedure is being used to calibrate the pocket meter? We use a calibration solution. It's basically a known conductivity that'll calibrate the meter before every use. And then it says, do you prefer the turbidity tube versus a portable turbidimeter? And there's the nice thing about the turbidity tube is that it's easy to use. It doesn't require a lot of maintenance or calibration. We feel confident that folks can collect consistent info, and it's relatively inexpensive. There's other options for measuring turbidity out there, but we found that this is sort of the best sort of middle road where we're collecting useful information that's easily trainable and at a reasonable cost.
Okay, there's some questions about what the rules are in Virginia, the regulations, and probably not worth getting too deep into that, but turbidity criteria, as Jake said, they can be a narrative. You don't cause turbidity in a stream, or they can be numbers. Either way, if one or the other fits, this monitoring can do us some good in figuring out what's going on there. So I won't try to get too deep into that.
And I just saw that Autumn and Misty posted a link in the chat box to a Google sign-up sheet. This is a way that you can go ahead and let us know that if you're in West Virginia and Virginia, you can go ahead and let us know that you're interested in getting involved. So if you open the chat box and click that, it's just asking for some really basic information to help us follow up with you. We'll also, like Dave said, he'll be following up with folks via email tomorrow, so we'll have the opportunity to connect with us that way as well. But this isn't the end. This is sort of the intro, and West Virginia Rivers and Wild Virginia will kind of take it from here to help provide additional guidance and match you with a good place to do this work.
Okay. I guess our time is almost up. I'm just looking to see if there's any other questions. Industrial wastewater treatment with land application. it doesn't happen a lot in Virginia. There may be other localities where they do quite a lot of that, but not really here. So I can't tell you a lot about monitoring about it. And
There are quite a few questions, so I'll go ahead and capture these. And then when we do our follow-up calls and Zooms, we can try to get to a few more of those.
okay. All right.
All right. So, well, thank you all for your time today. Hopefully it was worthwhile for you and you learned something, and appreciate your interest in protecting your local streams and rivers.
Thanks, everybody.
Thanks, everyone. Have a good night.